Do I need to do any other settings? It's fine. Okay. Then I think, oops. Okay, the next speaker is Toru Yamasaki, and he's going to show some interesting research on the gabbro sequence in the Oman ophiolite. Please go ahead.
Okay, from now, I'd like to talk about ophiolite case. The origin of layered gabbro in ophiolite and oceanic crust is an old but modern problem. The fundamental question is how the horizontal layered structure of gabbro was formed from vertically ascending magma. The sheeted dike complex here is a vertical feeder dike for the overlying lava sequence, but the underlying gabbro has sub-horizontal structure. There are two main models to explain this phenomenon. The gabbro glacier model assumes that all gabbros form at the melt length just below the sheeted dikes. The layered gabbros are the result of subsidence of subsequent subsidence. The multiple shell model explains the layered gabbro as a stack of many shells. Although this debate is still ongoing, the multiple shell model can be verified by study of cryptic variations. There have been some previous studies of cryptic variation in the layered gabbro sequence of the Oman ophiolite. Browning in 1984 reported interesting cryptic variations here. There are some symmetrical compositional variations and large compositional gap between each unit, like this. However, there are tens of meters between each sample, so there is no guarantee that this is a true picture. On the other hand, there is very detailed study for 20-meter section of layered gabbros. Although this result does not show a clear compositional variation, the study area is very limited and representativeness is still in question. In this manner, if we took these two samples from here, this one and this one, then the normal decreasing trend can be obtained. However, if we took these two samples, this one and this one, completely opposite features would be detected. This means that the different results are obtained from different random samples. So, the simplest but not easiest way to conclude this argument is sampling all the layers that make up the layered gabbro. The study area is the Wadi Havmilivah section, just right here, from hairline block of the Oman ophiolite. Actually, this area is not a typical cluster section of the Oman ophiolite. Typically, there is 2 to 5 kilometer thick layered gabbro sequences between the moho and the sheeted dikes. But there is this area is characterized by thick laminated gabbro-norite, fine-grained laminated gabbro-norite. This type of gabbro, this type of gabbro characterized by very calcic plagioclase and interpreted as a product of hydrous arc-type magmatism at later supra-subduction zones magmatism. Anyway, existence of this type of gabbros and relatively large amount of danite whale-like intrusion, so-called late intrusive, constrain the timing of intrusion and can be expected to be a clue for understanding the original mid-ocean ridge type cryptic variation. The layered gabbro show rhythmic modal layering like this. at least in part, and grading-like structure is also observed in some cases. This type of thin alternation of plagiocrest-rich layers and olivine and pyroxene-rich layers are also commonly observed. Here is a boundary between the mantle Harzbarger tectonite and the layered gabbro. So here is a moho. So we took 704 samples from here to here. The analysis is time consuming and still ongoing. So today's talk is preliminary results from only this thin lowermost sparse portion of the layered gabbros. For example, we took 3 samples from this area. This boundary is here, and this boundary is here. This is a result of cryptic variation in 45-meter section of the layered gabbro from the moho. In a broad view, some parts show smooth tendency, like this and like this, like general cyclic variations, while others are highly disturbed. If we look at the details, this apparent duplicate or double variation trend is actually some zigzag patterns like this correspond to layer boundaries. Lithological change is not significant, thus it's a certain cryptic variations. For 6 to 16 meter interval, monotonous signal single decreasing trend correspond to thick olivine gabbro layer. In this case, we have some modal layering in some portions around here, but not, for example, this olivine rich layer shows slightly MG rich features here, just like this, but not so clear within the overall decreasing trend. The interesting interval is this wavy compositional variation. Lithological difference is not significant also, but magnesium portion corresponds to olivine rich part within the single layer. This magnesium portion is this olivine rich layer. Large compositional gap also correspond to layer boundaries. The multiple cell model predicts normal differentiation within a cell at the constant pressure. Increasing pressure of the individual cells led to sudden upward migration of residual melt, and phase and modal change occurs. Such sudden decrease of crystallizing pressure. The additional key occurrence is danite late intrusion. This intrusion clearly intruded into layered gabbro sequence and enclosed its gabbros, but branch of this body intruded coherently into the layered gabbros like this. In addition, we can see many symmetrical layers like this within the layered gabbro sequence. Plagiocrest-rich portion commonly exists at the center of these danitic layers. For example, here, here, and here. So we prefer to interpret such an overall phenomenon as flow differentiation. The classical study of analog experiments by Bacciargi 1967 show parabolic velocity gradient profile. This velocity gradient results in actual concentration of solid crystals within the migrating melt. It is expected that earlier crystals concentrated in the center of the case of gabbro series. For dendritic series, I'm not sure, but probably large density contrast results in concentration of radionucleus in the center of series. So the complex cryptic variation of layered gabbros in the study area most likely shows a pile of many series. Smooth trend using thick layers correspond to flow differentiation patterns. In particular, this type of parabolic trend would be formed by parabolic density gradient of parental magma. On the other hand, sudden large change of mineral compositions like this, clearly indicates seal-like intrusion of different stage of differentiation. In fact, a similar relationship can be observed at the seated dike complex. In the seated dike complex, chilled margin on one side only is often observed. This occurrence indicates that a new dike has penetrated an existing dike. So we probably see similar phenomena of kryptonic phase in the layered gabbro sequence. The sharp lithological boundaries like this in the outcrop do not contradict this idea. Thank you for your attention.
Thank you very much. Any questions? There's one in the back.
Yeah, so you studied that you mentioned about the flow differentiation. So did you study the grain size distribution? Because I have understood that at the middle part of the flow there should be bigger grain size.
I'm not sure, but apparently not so large grain size variations within the seal.
Okay. Anyway, it was nice talk. Thank you very much.
Thank you.
Given that you show a lot of sills, do you also see dikes that are feeding these sills? The gabbroic section, ultramafic section? You see a lot of sills here. That
Yes.
Do you see the feeder dikes that are feeding these sills?
No, that's a great mystery for the ophiolite study.
Okay, so everything's going this way, nothing's coming this way.
Thanks. What do you see as the time difference between the whirlite related second phase intrusions and the first phase actual ophiolite? How much time do you see it occurring between those two?
I think it's a quite short time because intrusion is only on rich regions.
Okay, because the second phase intrusion.
You mean late intrusive?
The second group of intrusion with the whirlites, etc.
You mean this type?
That type of thing, yes.
It's not so long time interval.
But it is a distinctly different environment of intrusion. Because all of the second phase granitic type intrusions go with the whirlites, whereas the true plagiogranites is what worry about how people define that to go with the first phase on axis, whereas the second phase is distinctly off axis and supersubductions.
Yeah. Totally supersubduction zone settings. Many researchers thought subduction was initiated from the spreading axis, just after the spreading, just like this.
But it's also very noticeable that while you're having spreading axis magmatic activity at one end down the southeastern end of the Somali ophiolite. You're having supersubduction occurring simultaneously up at the northwestern end.
I think we can continue this discussion afterwards and we'll go to the next talks. Thank you very much, sir. Yes.